This short video will demonstrate how to calculate the velocity at a certain instant, particularly with an object that has a constantly changing velocity. So there's two main methods that we can use this. The chord method is the one that actually uses average velocity. But the tangent method truly does identify the velocity at a certain instant. So line, first example, I'm going to demonstrate the chord method for calculating the instantaneous velocity. So on a graph that is a curve, we could calculate the average velocity. So if you could recall the velocity, the average velocity is equal to the change in position divided by the change in time. So if we took this point at 0 seconds and wanted to calculate the change in position in this length of time, we could calculate this average velocity. So we understand that this delta x is minus 2 meters, and this delta t is 4 seconds. So in this example, the average velocity is -1 meter per 2 seconds, or -0.5 meter per second. If we are wondering, though, at 2 seconds, what is the velocity of this object at 2 seconds? If we did a tangent line to this, and a tangent is a line for this object's motion, the curve, if suddenly the curve stopped curving, and you drew a line off of this line, off of this curve at the trajectory that it would have continued on, that tells us what the slope at that instant would be. And if you recall, the slope of a position versus time graph tells us velocity. So I'm going to take a second and try to get rid of this line that I just drew on here. And so the new line, since we have already calculated the average velocity from 0 to 4 seconds, the point exactly in the middle of that time period is going to be parallel. The line that would be produced at that instant is exactly parallel of our instant velocity, of our average velocity. So the average velocity from 0 to 4 seconds is equal to the instantaneous velocity at 2 seconds. And that's true for any two chords that you choose. So if you decided you wanted to calculate the average velocity between I'll do a couple different colors here. Between 1 and 5 seconds, so this would be the chord line drawn from 1 to 5 seconds. It would look something like that. At the instant of 3 seconds, you see that this line, this 3-second line, is parallel to the line from 1 to 5 seconds. So we could calculate the slope of this line. You can see that it is at about, the delta x here is at about -0.9 perhaps. And then the delta t is 4 seconds. So for this instant at 3 seconds, that is a line that is parallel, this line that is parallel to the chord line, the slope would be equal to the average velocity of negative 0.9 meters over 4 seconds, which is negative 0.225 meters per second. So this is the second method of determining the velocity at a certain instant. So I had meant to use the same graph, but see if you can recognize what is the difference between this trend and the previous one. The purpose of this method is to identify the velocity at a certain instant. So just like in the chord method, where we care about what is the velocity at a certain time, we can use a computer program to run those calculations for us. So I used the same trend as I did in the chord method. And so previously we took the average velocity from 0 to 2 seconds and then ran a parallel line at 1 so that it would intersect at 1 second. Now, in this time, we can use a computer program to calculate something called the tangent for us. So you click in the menu bar where it says Analyze, and this option of Tangent is available. And you get this little helper box right here. And since we want to examine the graph, so we click that button, Examine, and it shows you this line so that when you put your cursor here at 1 second, you can see with this bar tells you where the cursor is. And the last portion is we want to interpolate, which means we want to consider all of the points in the entire range within the 3 data points that have been collected. So, so if we started at 0 seconds, if we wanted to calculate, if we wanted AvgVPro to display the tangent line at 0 seconds, you would put your cursor just about 0 seconds, and you can see the slope of this little line right here, this little black tangent line, demonstrates that the slope is -2, which it's important to understand what that relates to on our helper box for the trend. So if you were able to put your cursor on exactly 2 seconds, you can see that the slope is just about 0. So if you were looking at this right here, it would be about 0. And then let's say we went to 3 seconds. You can see that the slope is listed there. So the slope is listed right up here. Alright, so let's consider the component that we did for the chord testing for this same trend. Previously, the value was whatever we calculated it to be, and now you see the slope is there. So remember, this is the mistake, so this is different than the trend that was done in the last example. It's really important that you consider the units, because this is the slope of a position versus time graph. And I would like you to recall what the slope of a position versus time graph demonstrates for us. That concludes the discussion of how to use a graph to calculate the instantaneous velocity for an object that has a changing velocity. And the last thought I'd like to leave you with is, if you could, do you know what a shark's favorite sucker is? So if you have any other questions, feel free to see me in class. Have a great PSAT day.